Method to solve the quadratic equation. Just as a reminder, the three methods that we've learned, there's factoring and the zero product property, there's the quadratic formula, and you can also take the square root. For number 11, this one's set up perfectly to take the square root of both sides. You have something squared equal to another number, so I can go ahead and just take the square root of both sides of this equation. So the square root of x squared is x, and then the square root of 27 is positive or negative square root 27. And it says you need to write your radicals in simplified form. So if I were simplifying the square root of 27, I could rewrite that as, there's a pair of threes, 3 root 3. So x could be equal to positive or negative 3 root 3. Just remember, when you're solving a quadratic equation, since it's squared, there's going to be both a positive and a negative answer. For number 12, this one is set up really nicely for factoring and using the zero product property. You could factor this trinomial. You need factors of 30x squared that add up to 11x. So I could use 5x and 6x. And if I factor out a 6, one of my factors would be x plus 6. And one of my factors would be x plus 5. So that's factored, and then I could use the zero product property by setting each of these factors equal to 0 and solve. X would either be negative 6 or x would be negative 5. You can also use the quadratic formula for this one. Remember, the quadratic formula is the opposite of x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And you would just substitute in your a value of 1, your b value of 11, and your c value of 30. And you just plug those in for a, b, and c, and you should come up with the same two answers. For number 13, we can try factoring out a greatest common factor. In this case, both of these terms are divisible by negative 3, and they're also both divisible by x. So I could factor out a 3x, and then negative 3x times x would be the 3x squared. Negative 3x times 5 would be the negative 15. So now it's in factored form, and I can use the zero product property, setting each of these factors equal to 0.
Okay, well, fix this one now, though.
Whoops, that should be a minus 5, sorry. You could also use the quadratic formula. In this case, the a value would be negative 3. The b value would be 15, negative, and the c value is just a 0. And you just substitute those numbers in to the quadratic formula, and you should end up getting these same two answers. And the last one, number 14, we could just take the square root on this one, but before you can do that, you have to set the equation. You can't have anything else but the square. Oops. Equals -2. Okay, so what we're going to have to do is take the square root of both sides, and it looks like we're going to have imaginary roots. So if we take the square root of both sides, the square root of x plus 5 squared would just be x plus 5. And then the square root of -2 is going to be I times the square root of 2, positive and negative. And then I need to solve for x, so I'll subtract 5 from both sides. So it would be -5 plus or minus I square root 2. So these are imaginary roots.